Hi all, welcome to DS Tech. In this video, we are going to see about the subject basic electronics and electrical engineering in the regulation 2020-25 for the Department of Electronics and Communication Engineering and for Department of Biomedical Engineering. We are going to see about the unit 2 named as electrical machines. In that we are going to see about different electrical machines like DC generator, DC motor, and then the type of DC generator, brushless DC motor, alternator, single phase induction motor, three phase induction motor, and then transformer, ideal transformer. These are all the electrical machines we have discussed in this lesson. The first thing we have to know about this topic is electrical machines. What is electrical machines? Like that we have to understand first. Okay. An electrical machines is an electromechanical energy conversion device. It is converting the electrical energy into mechanical energy in the applications. Okay, the device which converts the electrical energy into mechanical energy is called as motor, and the device which converts mechanical energy into electrical energy is called generator. This is the basic difference between generator and motor. In generator, the mechanical energy is converted to electrical energy, and in motor the energy is converted from electrical to mechanical. Okay, and this is the block diagram for electrical machines, where the mechanical energy is converted into electrical energy, or else the electrical energy is converted into mechanical energy. Okay, and then we have in the next topic we have to see about the construction, operation and working principles of DC generator. Okay, in DC generator is a machine which converts mechanical energy into electrical energy. Okay, it is used on the direct current, so that it is called as DC generator, which are used to supply power for radio equipment, battery charging, electrolytic cells, like that. So the disadvantages in common DC machine is the design complexity and the usage of brush gear, like that. These are all the disadvantages. And then in the construction of DC generator, it consists of two main parts, like stator parts and the rotor parts. The stator part is called a stationary part, called the field structure, which is mainly used for producing the magnetic flux. And the rotating part is called armature, where the mechanical energy is converted into electrical energy, or the electrical energy is converted into mechanical energy. Okay, only the rotating part is used to determine the machine is whether want to acting as the generator or else the motor. Okay, the stationary part and the rotating parts are separated from each other by an air cap. See, this is the diagram for DC generator. In this diagram we can able to see there is a five different parts like armature slot, yoke, shunt field, main pole, armature. And the armature slot is responsible for the even driving of magnetic field throughout the entire coil, and the yoke is the outermost cover of the DC generator. The shunt field coils are responsible for the flux creation, and the main poles are used to work in correlation with the armature slot. Okay, this is the DC generator. See, this is the structure of DC generator. There is a part like bearing, shaft, fan, end bracelet, armature, frame of stator, commutator and brush. The detailed explanation of the parts will be seen below. The main parts of DC generator is, the first one is yoke. As I said earlier, the yoke is the outermost cylindrical part of the machine, which is made up of solid cast iron or cast steel or a forged steel. The yoke acts as the protecting cover of the machine and also provides a return path for magnetic flux created by field windings. In small DC machines, yoke is made up of cast iron. In large DC generators, the yoke is made up of cast steel from consideration of better magnetic properties. And then the second one is poles. The poles are also called as field magnets. It consists of pole core, pole shoe and pole coils, where the pole core is made up of cast steel or forged steel, where the or else in some machine it is made up of laminated sheet. The pole core holds the pole's coils. Then the pole shoe is the lower portion of the pole. The main function of the pole shoe is to support the field coil and spread out the magnetic flux in the air gap. And the if the pole shoe is made up of large cross section, it reduces the reluctance of the magnetic path. See, this is the pole shoe and the poles. And then the third one is field coil. The field coils are wound on pole cores and which is connected in series, and the connections are arranged on different poles, so that when a current is passed through this winding, the poles get magnetized to N and S poles alternatively. So the field system is responsible for producing the required work flux in the air cap. The field coils are also made up of enameled copper wire. The fourth one is armature. The armature is the part of the DC machine where an EMF is induced as it rotates to the main field. And the armature consists of toothed core like armature slot as we named. A winding dropped in the core slots and the commutator mounted on the armature shaft. The iron material is used for armature core. The rotation of solid iron core in the magnetic field results in eddy currents. The eddy currents flows in the core, which may causes the wastage of energy and heat dissipation in the armature. To reduce the eddy current, the armature core made up of thin silicon steel laminations. The laminations thickness may vary from 0.4 to 0.5 mm and then insulated with varnish. And the armature windings consist of different sections and coils, which is housed in the slots on the surface of the armature. The conductors of each coils are so spaced that when one side of the coil is under north pole and the opposite side is under the south pole. Depending upon the matter of the armature conductor connected to the commutator, there are two types of armature winding like lap winding and wave winding. In lap winding, it is suitable for low voltage high current generators, and the wave winding is suitable for high voltage low current generators. Generally, the lap winding is used for the generators where the capacity is more than or equal to 500 amps, and in lap winding the number of parallel paths is equal to the number of poles in the machine, where the number of parallel paths is represented as P and the number of poles in the machine is represented as A, which is equal to each other. In wave winding, it is mainly preferred for generator which is having the capacity less than 500 milliamps, and in wave winding the number of parallel paths is equal to A, and also the number of brush required is also equal to 2. This is the commutator segment. In lap winding, the number of poles and number of winding is equal to each other, and in wave winding it is not equal to each other, but the value of A is equal to 2. The the next one is commutator. The commutator is a typical component of DC machines which is used to collect the current from armature conductor, and which is a hollow cylindrical structure and made up of high conductivity hard drawn copper materials. The segments are insulated from each other by the thin layer of mica, and it is used to convert the EMF induced in the armature conductors to unidirectional voltage across the load impedance. The sixth one is brushes. The main function of the brush is to collect current from the rotating commutator and deliver it to the external load impedance, where the brushes is made up of carbon material and the brushing is mounted in a box type of brush holder and held on the commutator by the help of a spring. In bearings, then the seventh one is bearings. In bearings, it is used to help the rotor shaft to rotate smoothly. So the ball bearings or roller bearings are preferably used. For small machine, ball bearing is used, and for heavy, roller bearing is used. Here also there are two types like lap winding and wave winding. In lap winding it is also suitable for low voltage and high current, and the wave winding is suitable for high voltage and low current. Then we can discuss about the operation of DC generator. See, this is the diagram of DC generator, where it consists of two poles like north pole and south pole, and it is made up of load, carbon brush, slip rings, and then there is a rectangular winding like A, B, C, D. Once there is a flux, creation of flux, it moves from the north pole to south pole with the direction indicating the direction AD to BC. So, considering a single down loop, ABCD is rotating clockwise direction in a uniform magnetic field with a constant field. Whenever the loop starts rotates, the flux is induced in the coil of sides AB and CD changes continuously. Therefore, the EMF in the coil is also induced changes, but the EMF in one cell coil adds with the induced in the another. Then the EMF equation we can discuss about the EMF equation of the generator. We have few considerations like P, which is called which is denoted as the number of poles, and pi, which is equal to flux per mole, which is measured in Weber, and Z, which is equal to total number of armature conductor, which is equal to number of slot into number of conductors per slot, and N is denoted as rotational speed of armature in RPM, and A is equal to number of parallel path in armature, and E is equal to the general EMF per parallel path in the armature. So that the average EMF generated per conductor is equal to d pi divided by dt, and the flux conducted per conductor is one revolution is equal to d pi equal to b pi, which is in measured in Weber, and the number of revolution per second is equal to n divided by 60. Time for one revolution is dt equal to 60 divided by n seconds. Hence, according to Faraday's law of electromagnetic induction, EMF generated per conductor is equal to P pi n divided by 60 volt. For a lab wound generator, number of parallel path A equal to B, and the number of conductors in one path equal to Z divided by P, where Z equal to, we know that, where Z is equal to total number of armature conductor and P is equal to the number of parallel path. For a wave wound generator, the number of parallel path equal to A equal to B. The number of conductors in one path is equal to Z divided by 2. So the EMF generator per path is P pi Zn divided by 120 in volt. In general, generated EMF is Eg equal to pi Zn divided by 60 A, where A is for lap winding, A equal to B for lap winding, and A equal to 2 for wave winding. And then we discuss about the type of DC generators based on the method of exciting field coils. There are two, like separately excited DC generator and self-excited DC generator. In self-excited DC generator, there are three categories like series generator, shunt generator, compound generator. And in compound generator, there are two, like long shunt generator and short generator. These are all the classifications of type DC generator. In the separately excited DC generator, the field coils are excited from an independent DC source. See, in this DC generator, one side is connected with the DC supply and the other end is connected with the load of rotating armature. The greater the speed and the field current, the greater is the generated EMF in the separately excited DC generator. So we can measure that the armature current IA is equal to IL and the terminal voltage V is equal to EG minus IA RA, where EG is the flux that is excited. The electric power developed is equal to EG into IA. Power delivered to the load is equal to voltage into armature current. In self-excited DC generator, the excitation of field coils are done by feeding back a part of the output of the generator. These generators are the having the field magnets which are energized by the electric current supplied by themselves, so that it is called a self-excited. It can excited by their own. In this type of machines, field coils are internally connected with the armature. So due to the residual magnetism, some flux is always present in the pole. So when the armature is rotated, some EMF is induced and hence some induced electric current is also produced. The small electric current flows through the field coil as well as the load, strengthening the pole flux. In self-excited only, there are three types like series wound, shunt wound and compound wound. See, we can see the series wound here. In series wound, there is a field coils which are connected in series with the armature conductor, and the whole electric current flows through the field coil as well as the load. As a series field windings carries full load current, they consist of relatively few turns of thick wire. The electrical resistance of the seal winding is therefore very low. This is called a series wound generator, where we can related its expression as series coil resistance RSC, and ISC is the current flowing through the series field resistance, where IA equal to ISC equal to IL equal to I. We can consider it as all the current is equal to the total current I, and then the voltage across the load is V equal to EG minus I into RA plus RSE minus V brush, where V brush is the indicating the drop by the brush, and the power generated is equal to flux into current, and the power delivered to the load is equal to voltage into current. The next one is shunt wound generator. You can see here, in shunt wound generator, the field coil is connected in parallel with the armature conductor. See, in the series wound resistor, the field coil is connected in series with the armature conductor, and in the shunt wound generator, the series coil is connected in parallel with the armature conductor. Then the last one is compound wound generator. It is a combination of few series and a few shunt windings. It may be either short shunt or long shunt. In a short shunt compound wound, the armature and shunt field windings are connected in parallel, and the series field windings are connected in series with this combination. See, in this diagram we can see the short shunt wound generator and long shunt wound generator. In short shunt, the armature and the field coils are connected in parallel with the armature conductor and in series with the series coils, and in long shunt the shunt components are connected in series field and connected in parallel with the shunt field. This is the cumulative compounding and differential compounding structure. And then when we move on with the applications of DC generator, the applications of the DC generator for separately excited DC generators, it is more expensive than self-excited DC generator because of their requirement and because of the ability of giving wide range of voltage output. They are used for testing purpose in the laboratories. Separately excited generator operated in stable condition with the variation of any field excitation. They are used as supply source of DC motors whose speeds to be controlled for various applications like wall Leonard systems of speed control. And for shunt wound DC generators, it is used for its dropping voltage characteristics. They are used to supply power to the apparatus situated very close to its position. They are used for general lighting, they are used to charge battery, they are used for giving the excitation to the alternators, and used for small power supply. In series wound DC generator, this type of DC generators are restricted for the use of power supply because of their increasing terminal voltage characteristics with a rise in the voltage current from no load to full load. so that they are used for supplying field excitation electric current in DC locomotives for regenerative braking, and used as boosters to compensate the voltage drop in the feeder in various types of distribution systems such as railway service, etc. And in series arc lighting, this type of generators are mainly used. Then the applications of compound wound DC generator. The compound wound DC generators used mostly than other type of DC generator because of its compensating property. In cumulative compound wound generators are used for lighting, power supply purpose, and for heavy power services. Used for driving a motor and small distance operations like hotels, office, homes, lodges, etc. And the differential compound wound generators are used because of the large demagnetization armature reaction and used for arc welding, where huge voltage drop and constant electric current is required. Okay, these are all the applications of DC generators. In the electrical machines too, in this topic in the unit chapter 2, we have seen about the electrical machines, about DC generators, constructions of DC generator, working principle of DC generator, its EMF equations, and then the types of DC generators and its application. Hope this video is useful for you, and thanks for watching. Thank you.